All right, here we're going to be looking at finding the volume of a shaded region. So it's going to be a volume that's surrounding an unshaded region. The general idea here is really simple. We're going to find the total volume and then subtract away the unshaded part. The leftover part will be the shaded region. So I'm thinking about finding the whole volume of that triangular prism, which means I'm going to use capital B times H, so the area of the base, times the height of the prism, and then I'm going to subtract out the volume of that cylinder, which is pi r squared times H. The leftover part is going to be that shaded volume that's surrounding that unshaded cylinder in the middle. So I'm thinking about the area of the base. That is a triangle. This is my whole base. So I'm thinking about 1/2 base times height, or 1/2 of 12 times 5, or 30. So the area of the base is 30. The height that connects my two bases, the triangle in the front, triangle in the back, is 8. So the full volume is 240. So that's everything inside of there, including that unshaded cylinder. That's really the problem. I have to get rid of that unshaded cylinder, and that leaves me with the leftover part, which is the shaded volume. So I'm going to find the volume of that using pi r is given to me. That 3 is the radius, so I'm going to use 3 squared, times the height of the prism, the height of the cylinder, which is actually also the height of the prism. It's going from one end all the way to the other, so that's 8. So then from there, we're going to multiply 72 times 3.14 and get that the volume of that cylinder is 226.08, which seems surprisingly big. Actually, I'm just looking at this now and thinking about the height of that cylinder. So the radius is 3, so that means the entire height there has to be 6, which means it really can't stand up inside of there. If the length of that is 6 and the height of that prism, it's not really the height of the prism, height of the triangle is 5, that really couldn't be contained within there. I'm going to just pretend that's not the case and just keep going with this how it's supposed to be. But really, that cylinder is too big to fit inside of that triangular prism. But our last step is really just subtracting out that unshaded part. Let's pretend that does fit inside of there, and that would be about 14. Actually, I'm just going to round that to 14. And we're talking about volume, so it's feet cubed. So you're going to be thinking about the volume of that shaded region again, so it's the same kind of logic. I'm thinking about the entire volume of that rectangular prism. That's length times width times height. And then I'm going to subtract out the volume of this unshaded pyramid that's squeezed inside of there. So I'm thinking about volume of the rectangular prism, length times width times height. And that's 16 times 9 times 8. And then I'm going to subtract the volume of that pyramid. 1/3 capital B stands for the area of the base. The area of that, which is really what I use for length times width there, 16 times 9. And then times the height. It's not totally clear, but actually this is going up to the peak of that. That 8 is actually measuring the height from the base of that pyramid all the way to the peak. So we multiply those out, and we get 1,152. Multiply these together, and we get 384. Yep, 384, and then we take that away from 1,152. And we get that the leftover shaded volume there is 768 feet cubed.